Class 9 Science, Chapter 3, Atoms and Molecules, and in this video I am going to explain answers of exercise questions of NCERT textbook. Question number 1. 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. Percentage means out of 100. Okay. These things are given in the question. Mass of boron, mass of oxygen and mass of sample. From this we can say it is 0.096 gram boron is obtained from 0.24 gram. Then how much boron will be obtained if sample is 100 gram? This we have to calculate. Okay, that's why percentage of boron by weight in the compound is 0.096 divided by 0.24 multiplied by 100, and if we solve it we will get answer 40%. In the same way, percentage of oxygen by weight in the compound, this is the mass of oxygen divided by mass of sample multiplied by 100, and if we solve, its answer will come 60%. When 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burnt in 50 gram of oxygen? Which law of chemical combination will govern your answer? This is the reaction taking place in this carbon react with the oxygen form carbon dioxide, and this is the chemical equation. C plus O2 gives CO2. In the question it is given 3 gram of carbon reacts with 8 gram of oxygen to produce 11 gram of carbon dioxide. Actually, this we can say there is the 3:8 ratio by mass of carbon and oxygen in carbon dioxide. Okay. If 3 gram of carbon is burnt in 50 gram of oxygen, then 3 gram of carbon will react with the 8 gram of oxygen according to this mass ratio. The remaining 42 gram of oxygen will be left unreactive. In this case also only 11 gram of carbon dioxide will be formed, and the above answer is governed by the law of constant proportions. What are polyatomic ions? Give examples. Groups of atoms carrying a charge, charge may be positive or negative, are called polyatomic ions. For example, number of ions are there which are polyatomic. Few examples are here. Ammonium ion, that is NH4 plus. Carbonate ion CO3 2 minus. Write the chemical formulae of the following. Magnesium chloride. Again you have to know the valency of cation and Ni. Magnesium valence is 2. Chloride Cl valence is 1. If you interchange these, okay, then you will get this is MgCl2. In case of calcium oxide, this is Ca valence is 2. Oxide valence is 2. Again if you interchange these valencies, you will get that is Ca2O2. But the simplest ratio of this 2 is to 2 is 1 is to 1. That's why answer is CaO. Copper nitrate. Copper show 2 valency, 1 and 2. But if it is not mentioned, then consider copper is present in the second valency. That's why valency of copper is 2, and nitrate, that is NO3, valence is 1. Again if we interchange, we can say here this NO3 is a polyatomic ion. When polyatomic ion comes more than once, then this is enclosed in this bracket, and the how many times it is coming, it is written as a subscript outside the bracket. That's why this is CuNO3 twice. The same way aluminum chloride AlCl3, calcium carbonate CaCO3. Give the names of the elements present in the following compounds. Quicklime. If you know the formula of this quicklime, then you can find out the name of elements present in this. Its formula is CaO. From this formula we can see elements present in this calcium and oxygen. Hydrogen bromide, its formula is HBr. That's why we can say elements are hydrogen and bromine. Baking powder, its formula is NaHCO3, and its name is sodium hydrogen carbonate. And by observing this formula, we can write the name of elements: sodium, hydrogen, that is carbon, and oxygen. Potassium sulfate, first write its formula. This is K2SO4. Elements are potassium, sulfur, and oxygen. Calculate the molar mass of the following substances. Ethyne C2H2, formula is given. Okay, and that's why ethyne C2H2, 2 atoms of carbon multiplied by atomic mass of carbon plus 2 atoms of hydrogen multiplied by atomic mass of hydrogen, and if we solve it, we will get 26 gram per mole. Okay, this is the unit of molar mass. Sulfur molecule as 8. In one molecule of sulfur, there are the 8 atoms of sulfur are present. Okay, that's why this is 8 is multiplied by atomic mass of sulfur, that is 32. If you solve it, 256 gram per mole. In the same way, phosphorus molecule P4, atomic mass of phosphorus is given 31. That's why this is 4 into 31, 124 gram per mole. Hydrochloric acid HCl, that is 1 atomic mass of hydrogen plus 35.5 atomic mass of chlorine. This will 36.5 gram per mole. Nitric acid HNO3, this is 1 plus 14 plus 3 into 16. If you solve it, we will get the answer 63 gram per mole. What is the mass? You have to find out the mass, and mole is given. Our basic formula is this: if mass is given and then if it is divided by the molar mass, then we will get the number of moles. Okay, but in this question, mole is given. Okay, and what is we have to calculate? We have to calculate this small m. Then we can say this small m is equal to n into m. In this question, n is given, that is 1 mole, and molar mass of nitrogen atom is 14 gram per mole. That's why 1 mole multiplied by 14 gram per mole, our answer is 14 gram. The same way, 4 moles of aluminium atoms, atomic mass of aluminium is given. And this atomic mass, this is numerically this is equal to the molar mass of aluminium atom, but this is expressed in gram per mole. That's why mass of 4 mole of aluminium atom is 4 mole into 27 gram per mole. Your answer is 108 gram. 10 moles of sodium sulfite Na2SO3. We use the same formula. M is equal to N into M. First, we have to calculate the molar mass of Na2SO3. This is 2 atoms of sodium multiplied by 23 atomic mass of sodium plus 32. This is the atomic mass of sulfur plus 3. This is we can say this number of oxygen atom multiplied by 16 atomic mass of oxygen, and if you solve it, 126 gram per mole. Okay, this is the mass of 1 mole of sodium sulfide. Then mass of 10 mole of sodium sulfide is 10 mole into 126 gram per mole, and this is 1260 gram. Convert into mole. Okay, 12 gram of oxygen. Again, mass is given and you have to find out the mole. Okay, our formula is this: N is equal to M divided by M. Given mass, in this case 12 gram is given, and species oxygen gas. That's why molar mass of oxygen gas means O2, not O, O2. Okay, that's why 2 into 16, 32 gram per mole. Put the value 12 gram divided by 32 gram per mole. If you solve it, 0.375 mole. 20 gram of water. Given mass is 20 gram and molar mass of water is 18 gram per mole. Use the formula. Put the value 20 gram divided by 18 gram per mole. This is 1.11 mole. 22 gram of carbon dioxide. In this case, given mass is 22 gram and molar mass of carbon dioxide is 12 plus 2 into 16, 44 gram per mole. Use the formula, this, put the value 22 gram divided by 44 gram per mole, and this is equal to 0.5 mole. What is the mass of? Again, you have to find out the mass, and what thing is given? Mole is given. Again, we This is our basic formula, and from this we have to find out this small m. Okay, and this n is given. M is equal to n into m, where m is the molar mass of oxygen atom, that is 16 gram per mole. Put the value, m is equal to 0.2 mole into 16 gram per mole. This will be equal to 3.2 gram. The same way, 0.5 mole of water molecules. Again, same formula. Small m is equal to n into capital M. Molar mass of water is 18 gram per mole. That's why m is equal to 0.5 mole into 18 gram per mole, and answer is 9.0 gram. Calculate the number of molecules of sulfur, that is S8, present in 16 gram of solid sulfur. First, find out the moles in 16 gram of sulfur. How many moles of sulfur present in 16 gram of sulfur? And for this we have to know molar mass of S8. That's why molar mass of S8 is equal to 8 into 32. This is 256 gram per mole. From this value and from this value we can find out the number of moles. Okay, and this is equal to n is equal to m by m. Put the value, this is 0.0625 mole. Now find out number of sulfur molecules in 0.0625 mole, and this formula we will use. N is the number of moles, n is the number of particles. These particles may be atoms and molecules. In this question, these particles are molecules. That's why number of molecules divided by Avogadro constant. In this case, this n we have find out already, this one. Okay, and we know the value of this Avogadro constant. We have to find out this n. That's why this is n is equal to n into Na. This, put the value, this is Avogadro constant, and this 0.376 into 10 to the power 23. If this decimal is shift to one place of right side, then this power of 10 will decrease by 1. That's why 3.76 into 10 to the power 22. There is another method. If we combine these two formulae, that is this one and this one, then we will get this one. Okay, and in this case we have to find out the value of this n. That's why n is equal to, this is m, small m divided by capital M multiplied by Na. Put the value, 16 gram. This is the mass of sulfur molecule is given. This is 256 gram per mole. This is the molar mass of sulfur molecule. This is Avogadro constant, and if you solve it, answer will be 3.76 into 10 to the power 22 molecules of sulfur. Okay. Calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. First of all, we will find out the mass of 1 mole of aluminium oxide, that is molar mass of aluminium oxide. This is 2 into 27 is the atomic mass of aluminium. Now again you have to remember, in this case that you were asked to find out the aluminium ions. But the mass of an ion is the same as that of an atom of the same element. That's why this the atomic mass of aluminium atom is given 27U. But in this aluminium oxide, aluminium is present in the Al3+, that is aluminium ion. The mass of Al3+ and Al is the same. That's why this is 27 plus 3 into 16. If you solve it, we will get 102 gram per mole. What is the meaning of this? It means 102 gram of aluminium oxide contain 6.022 into 10 to the power 23 units of aluminium oxide. Okay. That's why we can say then 0.051 gram of aluminium oxide contains, this is 6.022 into 10 to the power 23 divided by 102 multiplied by 0.051. If we solve it, 0.003011 into 10 to the power 23. Now in this case, if we shift this decimal to 3 place right side, okay, then this power will decrease by 3. That's why this is 3.011 into 10 to the power 20 units of aluminium oxide. These units of aluminium oxide are present in 0.051 gram. But we have to calculate number of aluminium ions. The number of aluminium ions present in 1 unit of aluminium oxide is 2. from this formula you can find out this is the 2. Therefore, the number of aluminum ions present in 3.011 into 10 to the power 20 units of aluminum oxide is equal to 2 into 3.011 into 10 to the power 20, and this is equal to 6.022 into 10 to the power 20. Okay student, thank you. Subscribe my channel to get the new videos of next chapter.